Hi students, my name is Samuel Chukwu Emeka. Good evening. In this video we shall discuss compound interest. Please, before you view this video, it is highly recommended that you view the video on simple interest. Yeah, the video on simple interest and all the prerequisite videos before simple interest. It is recommended that you do that. It is also recommended that you view the video on logarithms. I did a video on logarithms some time ago. It is recommended that you view that, especially as we do continuous compound interest. Now, for this video we shall focus only on compound interest, and the next video we can do continuous compound interest. Okay, what is compound interest? When we talked about simple interest, we talked about it and how we can deposit money in a bank or in a financial institution or in any interest yielding institution, and after some time, after some years, we get some extra money on that, and that extra money is what we call interest. Or when we borrow money from a financial institution and we are supposed to pay back after some time. So after some time we pay an additional fee on top of that money that we borrowed. That fee is called the interest. So that was simple interest. Now, when we talk about compound interest, it is still an interest, but it is an interest on an interest and also on the principal. Okay, it is an interest on the principal and also on the interest. In this case, in compound interest, we talk about an interest that is compounded. It is compounded. It is not like simple interest per se. Yeah. Well, it is similar to simple interest, but in this case it is compounded. Okay, in this case it's compounded. So we calculated a different. We use the same way we do simple interest, but the only thing is that we now compound that interest with the principal. Okay. For instance, let's say that you deposit. Let's say you deposit $1,000. Okay, you deposit $1,000 to a bank that pays maybe a 10% annual interest rate. Now, how much will you have after 3 years? After, let's say, 3 years, how much interest will you have? Okay, this is simple interest. Okay, why? Because they did not mention anything compounding. Now, for compound interest, they will have to say in the question that this interest is compounded. That is what they will have to say in the question. If they don't say it, okay, it is usually assumed to be a simple interest. So of course, with the simple interest, you remember in the video we did, this is PRT, and this will be 1,000 times, the rate is 10%, which is 0.1, times the time is 3 years, which is 3. And this will give you $300, right? Yeah, because this is $100, and then this will give you $300. So after 3 years, you will make $300 with a bank that pays 10% interest rate, 10% interest rate per annum, or 10% annual interest rate. We talked about that. So let's keep for this down that the simple interest, okay, simple interest is $300 in this question. Now, just keep for this question. Okay, just remember the question that we just wrote, because I need this board back. Yeah, until we start solving questions, I will need some space. So now assuming this money is compounded, let's say that the $1,000 that you deposited in the bank, that is compounded per year, assuming it's compounded per year. Assume the money, that's the $1,000, right, is compounded per year, is compounded per year at the same interest rate, okay? At the same interest rate, which is 10% per annum, right? Then after 3 years, let's see what happens now. Let's see what happens. After 3 years, so let's say you have here, then you have the amount, the principal, you have the rate, you have the time, and you have the amount. You know what? I would have. Let me just use the. Let me use the abbreviation. So you have principal, rate, time, amount. Okay. So with compound interest, this is how it works. Year 1. Okay, the principal is $1,000. Then the rate is still 10%, which is 0.1. And the time now this is compounded per year. It is compounded annually or per year. Okay, this is 1. So this will be what? $100. Okay, let's just put this, that this is in dollars, this is in year, this is in percent, or let's just leave it like this, then this is in dollars. Yeah, I know R is in percent, 10% is that 0.1. Okay, so you see that at the end of the first year, it will generate an interest. Oh, I'm sorry, this will be interest. Let's call this interest. Interest, which is in dollar sign, and then let's call this amount in dollars. So at the end of the first year, right, it will generate $100 interest at the end of the first year. And then the amount at the end of the first year will be $1,100. Now, since it is compounded annually, because this is compounded per year, right? So you now have to keep on compounding interest. You add interest on top of this principal. Now this amount is the principal that you originally had plus the interest that this principal yielded. Okay, so the principal, this amount is the principal plus I. We did that in the other video. Okay, now one thing with compounding is that this amount at the end of the first year will now be the new principal in year 2. In year 2, this amount will now be the new principal, $1,100. That will now be the new principal. So you see, it's like now you're finding interest on the principal and also on an interest as well. You see, you're finding interest on the amount, which is on the principal and on the interest. So in year 2, this will be 1,100. This is still the same rate. It is still compounded at the same rate, 10%. And then the second year, 1 year, okay, because this is per annum, per year. So this, if you multiply this will be $110, right? And you now see that with $110, when you now add it to find the amount, right? So what would it now be? $1,210. Okay, $1,210. So this amount is the amount at the end of the second year. This is the amount at the end of the second year. Okay, now you see the compounding now. Now you take this amount to be the new principal here. At the third year, you use that 1,210, and at the same interest rate, 0.1. Then 1 year, because this is per year, per annum. And when you do that, this is $121. Now when you add that, 121, this is 1331. So it will give us 1331. So this will be the amount at the end of the third year. Okay, so this is just the amount at the end of the third year. At the end of the third year, the amount at the end of the third year of 3 years, okay, the amount was 1331. But what was the interest? What was the now interest? The interest, of course, is 1331 minus the principal. Remember this formula, that the amount is the principal plus interest. So that tells you that the interest is amount minus principal. So this will be, amount is 1331 minus the principal you started with, which is $1,000. So the interest will be $331. $331. This is the compound interest. Okay, you can also find it by adding this. If you add up this, 100 plus 110 plus 121 will give you 331. So compare it. Compare this interest, the compound interest, with this interest here, $300, simple interest. So you see, which one is more? The compound interest. You see? So you gain more money with a financial institution that compounds interest. Okay? Although the difference now, what's the difference? The difference is $31. $31 is something, you know. Well, okay. So you see that with this case, this is the compound interest. This is the simple interest. The amount you gain at the end of this is 1,000 plus 300, which is 1,300. That's the amount you gain after 3 years. If it was simple interest, it will be 1,300. The amount you gain if it was compounded for 3 years, if it was compounded per year, will be 1,331. So you see that the one for compound interest is more. Okay, so let's look at this for instance and see whether we can do something here. Assuming I raise, so now what can we, from this now, what can we now say about compound interest? Compound interest is defined as the interest earned on a principal sum of money plus previous interest. So interest earned on principal and interest. So plus interest. So interest that is earned on principal plus interest. Interest earned on principal plus interest earned on interest. That will give you compound interest. Okay? Alright, now sum of principal, sum of money plus previous interest. So the interest earned on both will give you compound interest. Alright, now let's see whether we can derive a formula for compound. For compound interest, let's see whether we can find a compound interest formula. Now, one thing is this, with the simple interest formula, it gives you the interest, right? And then you have the formula for finding the amount. With the compound interest formula, it doesn't give you the compound interest. It does not. It just gives you the formula for finding the amount, or what we call compound amount. The amount that the future value, the amount that is received at the end of the compounding periods. Okay, at the end of the total number of compounding periods. That's what we call compound amount. Now, let's see whether we can derive a form, whether we can get a compound interest formula. Yeah. Of course, you know the simple interest formula is I equal to principal times rate times time. And then the amount after the simple interest is amount equal to principal plus interest, P plus I. Okay, which is P, 1 plus R root. Take note of what we got in the compound interest calculations. At the end of year 1, you know what we got. At the end of year 1, we got a 1110. That's the amount. At the end of year 2, we got a 1210. And at the end of year 3, we got a 1331. So take note of that. Okay. Now recall. Remember what we had from simple interest formula? From simple interest, we had that the interest, the simple interest is principal times rate times time. And we had that the amount is principal plus interest, right? So the amount is principal plus, when you substitute the value for the interest here from equation 1, you can call this equation 1. Equation 1, interest here is principal times rate times time. So if you substitute it into principal times rate times time, so the amount will be principal, because principal is common, P is common, then P divided by P is 1 plus P RT divided by P is RT. So I told you that we will need this. I told you we will need this. We will need this. Okay. Now this was what we did in the first video. All right. So now in this compound interest, because we want to see how we can find the compound interest formula. So in the compound interest, at the end of the first year, at the end of year 1, right, we had that our amount was 1110, right? So this amount was the same thing as principal, which was $1,000 plus the interest, which was $100, right? So the total amount, that was why the total amount was $1,110, because it was $1,000 plus the interest, $100. So this means actually, if we bring it back to this, this means that this is $1,000, right? 1 plus, now the rate we had was 10%, right? 10%, which is 0.1, and the time was per annum, per year, 0.1 times 1. 0.1 times 1. So this was what we had. The rate was 10%, 0.1, and the time is 1 year per year, because remember it was compounded per year. Okay, so now this is the first year. Now at the end of year 2, and you know what, if you do 0.1 times 1 is 0.1, plus 1 is 1.1. 1.1 times 1,000 is 1,110. That is what it is. Now at the end of year 2, we have that the amount, our amount was 1,210, right? Okay, so this means that this is 1,000, which is the principal, then 1 plus 0.1, because the rate was still 0.1, it was still 10% rate, then the time was per year, it was compounded per year. Now this now will be squared, and some of you might ask me, why did I write squared? I want to now find the compound interest formula. Okay, I want to find it to prove to you how it came about. Yeah, if you don't want to learn the proof, that is okay, but it's good to know that, you know, this squared means the second year. Just call it the second year, okay? Because you're compounding every year. So this is the second year. The second year. This means after 2 years. So let's see whether it's true. 0.1 times 1 is 0.1. 0.1 plus 1 is 1.1. 1.1. Now when you do 1.1 all squared, right? If you do 1.1 all squared, 11 squared is 121. So this is a 1, 2. It will give you 1.21, and you multiply it by 3 zeros. 1, 2, 3. It will give you 1210. Okay? So at the end of 3 years, you can easily find out what it will be. It will be 1000, which is the principal, then parenthesis 1 plus 0.1 times 1, because it was still compounded per year. So the time is still 1 year. It was still the interest rate of 10%, so arrow is 0.1. Then all cube raised to power 3. Okay, at the end of the year 3, if you want us to write it, you can write it. At the end of year 3, okay, it will be, what did we get as our amount? That was 1331. So this means that this is 1000 times 1 plus 0.1 times 1 raised to the third power. Now this 0.1 times 1 is 0.1, plus 1 is 1.1. 1.1 all cube. Okay, we probably wouldn't need to waste time here. I came with a calculator and I came with my laptop to show you how you can do some of this with the calculator or the computer. Okay, 1.1 all cube raised to power 3 will be 1.331. Then times 1000 will give you 1331. Now, I hope you know how to do 1.1 all cube. In your scientific calculator or in the calculator on the computer, you have this, you have the button like this, or sometimes you have it y raised to power x. Some calculators might have x raised to power y. Some calculators might have it just x cubed. Yeah, so if you want to find 1.1 raised to power 3. Now, provided you do not need to use shift or second function, you know, you should be familiar with your calculator. Provided you do not need to use it, if you have it like this, you can just say 1.1, then you press this symbol, and then you press 3, and then you press equal to. Yeah, that should give you 1.331. Yeah, so either of these, or you press y raised to power x. Just play with it in your calculator. Okay, so now, what does this tell us? This tells us that at the end of n years, at the end of n years of year n. Yeah, because at the end of year 1, you have this raised to power 1. Okay, at the end of year 2, you have this raised to power 2. At the end of year 3, you have this raised to the third power. So at the end of year n, you have a 1000, 1 plus 0.1 times 1 raised to power n. So this is what you have at the end of year n. Right? So that tells you now that this is A. Remember that our 1000 was P, and that this was 1 plus 0.1 was our R, and 1 was our T raised to power n. This kind of gives you an idea. Kind of gives you an idea of what the compound interest formula will look like. Okay? Kind of tells you what it will look like. All right. Now, but assuming, you know, this case was a case whereby we had to compound yearly. If we are compounding annually, that means it's just one time. So this was a case, if it's just one time yearly, it will work like this with this formula. All right. What if you were not compounding yearly? What if you were compounding 2 times per year, semi-annually? Or what if you were compounding 4 times a year, quarterly? Or what if you were compounding daily, 365 times in a year? You were compounding every day. That means 365 times in a year. How would you use the formula? So we now have a general formula. Okay? We now have a general formula, and it's going to look like this. The general formula will now be that A is equals to principal, then this is 1 plus R over M, then this is the MT. And I'm going to explain all this. I'm going to explain what it means, okay? Now, this is the first formula I'm going to give you. I'm going to give you another one, but let me explain what this is, okay? So we have A is the future value, or the compound amount, okay? P is the principal, or present value. R is the annual interest rate. M is the number of compounding periods per year. Okay, number of compounding periods per year. That's how many times do you compound it? You know, in our own case, this was just our own time was just 1 year. So with the interest rate, so this was like R 0.1 times 1. That's with our own time. Then T is the total time. Of course, in years. Usually in years, of course. Yeah, the time in years. This is the time in years. Just write time. Time in years. Okay? Now, M is number. Like number, so there's no unit for it. Then principal value or present value, of course, this is in dollars. In dollars, if it's America, it's in Naira, if it is Nigeria, or etc. And the same thing with A. A is in dollars, or in Naira, etc. Money, that's money. Okay? So this means this. Look at what this means. If you deposit a principal sum of money in a bank or a financial institution that pays an annual interest rate R, right? An annual interest rate R that is compounded n times in a year, then after T years, you will have an amount A. Let me repeat it. This formula tells you now, if you deposit some money, P, in a financial institution or a bank that has an interest rate R, has an annual interest rate R, compounded m times per year, compounded m times per year, then after t years, you will have an amount A. That is what it means. So now, what do you notice here? What do you notice here? You notice here that the compound, this is what we call the compound interest formula. Compound interest formula. Now, you notice that in this compound interest formula, there is no interest. You know, with simple interest formula, you have the interest. But in compound interest formula, there is no compound interest. It just gives us the amount. How will you find the compound interest? The compound interest will now be amount minus principal. That's how you find the compound interest. Okay? The compound interest will now be amount minus principal, just like the way we illustrated it. So that is what this tells you. Okay? Now, because of time, I won't need to write it. Now, another formula you will get sometimes, especially the one that is used in your textbook, you have A equal to P 1 plus I N. Now, this is another formula you might get here. Okay? Now, this is where here I, because I've defined A and P. I is the what? I is R over N. You know that I is R over N. Okay? I is what? The rate of compound annual interest rate, the annual interest rate per period. Annual interest rate of compounding per period. Rate per period. That's I. Okay. Annual interest rate of compounding per period. Then your N will be the total number of compounding periods. Total number of compounding periods. That's your N. Okay, so you might have it this, alright, or this. Now, remember what I said here. If you deposit an amount, P, or if you deposit a sum, P, to a bank that has an interest rate R, compounded M times per year, then after T years, you will have an amount A. If you want to use this one, this means if you deposit some money, P, to a bank that has an annual interest rate of compounding per period, I, then after a total number of periods, N, you will have an amount A. So take note of it. I know it's a lot of formulas, okay? But just, I hope you kind of understand how it works. You know, how I derive the formula, the basics with the one of yearly. Then from that one we can generate this. Okay? Now, it is like, I mean, it is something that you will need to practice. You just need to practice it. Okay? Yeah. All right. Let's do some calculations, and then we can call this video a night, and then do the continuous compounding later on. All right. Number one. Let's look at number one. Now, depending on the question you're asked, you know which formula to use. Okay? I've given you the two formulas. depending on the questions you asked, you know which formulas to use. Now, before we solve this is important. Let's see this. Let's see this. Let's see how we can get m. Okay? How do we find m? If principal, or let me say, if compounded, you know, this is both principal and interest. If compounded annually, right, m will be 1. Because annually means m is 1 time per year. Okay? So m will be 1 because this is 1 time per year. Remember? Okay? Now, if it is semi-annually, m will be 2. Okay? Which is because it's 2 times per year. 2 times per year. If it is semi-annually. If it is quarterly, then m will be 4. Okay? This is 4 times per year. 4 times per year. Then if it is compounded monthly, the m will be 12. This means 12 times per year. Okay? And if it's compounded daily, m will be 365. You know, usually we don't, I know that with leap year is 364, but usually we take a year as 365 days. So that is 365 times per year. Now, later on we can kind of do a question whereby we compare some money that is compounded yearly and some money that is compounded semi-annually, which one yields more money and the rest of them, okay? All right, but let's now do, so just take note of this, what m will be when it's compounded at so time. So you have those 2 formulas, okay? Depending on the question, you know which to use. All right, let's now do some problems. Number 1, find the future value A. They gave us P, they gave us N, they gave us I. So you will use A equal to P, 1 plus I, N. Okay? So they want us to find A. So our A will be, our B is 1500 times 1 plus I is 0.064 raised to power 29. Okay, please, I want you to pay attention now. When you're solving this, do not round. Please and please do not round on the way. Do not do that. I'm going to show you how to do it with your calculator or the computer in case. I hope you will see it well. Okay, or I can do technology, using technology to solve this. But do not round, please. Do not do that. You only round at the end. Now, A is going to be money, so we are going to round to 2 decimal places. Okay, now, if you're told to round to a particular number of decimal places, please do so. Now, if you're told to round to a particular number of decimal places as needed, if they say as needed, then it must not be that. So you just, if you get the answer like that, you just write it like that. If not, you round as needed. Okay, we will look at that, I think, number 4. All right. So in this case, you know, I'll kind of write 1500 times 1.064 raised to power 29. You see how I'm doing it one at a time? And this will be, A will be 1500 times, it's going to be a lot. So I'll tell you what to do. Okay, it's going to be a lot. 1.064 raised to power 29 is a lot now. 6.043760011. Okay, this is a lot, right? So what you want to do here is times 1500, and this will give you a 9,065.64. Okay, 9,065.64. All right, now you know, from my calculator, I just wrote everything here, but in the calculator on your computer, it's gonna be a lot of values, and you don't need to do that. So with my calculator, I'll just show you how you can just do this with my calculator. Well, this one is Casio 9750G plus. I don't know how many of you still have it, but you know, what you can do is you first of all do this exponent. Remember your PEMDAS. Now remember your PEMDAS. Please, you need to view this video. Yeah, PEMDAS. Ben, please excuse my dear Aunt Sally. Okay, bracket, parenthesis, exponent, multiplication, division, addition, subtraction. You do this exponent first. You have to do it first, and then whatever you get, you just multiply by 1500, and then you round up. Please don't come here and round up. Please don't do that. Okay, do not do that. Now, with my calculator, I don't know whether if you see it fine. What you need to do is this. With my calculator, you see my raised to power is here. My raised to power is here. So what I will do is 1.064 raised to power. I press raised to power 29, and then I press equal to first. I press equal to first. It gave me those values. Then I do times 1500, which gives me this. Now my raised to power is there. It is not on top of something, so I don't need to use my shift before I use it. Okay, so that is the way with my calculator. Now with the calculator on your computer, I've got to log on to this. Okay, with the calculator on your computer, you have to do it this way. Okay, when you log on to your computer, you want to go to start. Of course, you know how to get the calculator on your computer. When you go to start, right, you just type in calculator, or you go to accessories and get it, or just type in calculator and you press enter. Now when you come to your calculator on your computer, you have it as standard. So what you want to do is you go to view, change it to scientific. You change it to scientific and it becomes this, right? Then you want to look at the x raised to power y. They have it as x raised to power y. Some calculators have it as y raised to power x. Okay, so what you want to do is you do 1.064. Remember, the parenthesis was 1 plus 0.064. You do that first, the parenthesis. So you do 1, after adding it, you have 1.064. Then you press the x raised to power y, you press it. Okay, you press that x raised to power y, and then you press 29. And then you have to do equal to first. You have to do this with PEMDAS. You see the whole length of values it gave is a whole lot. Now you can come and start writing that down. Just immediately you do that, you just do times 1500. 1500, and that gives you, okay, I probably did something wrong here, so do it again. 1.064. You press raised to power x raised to power y, that's what you press, times raised to power 29. You do equal to first. You see the whole length of values it gave is too much. You just come immediately and do times 1500. 1500, and you press equal to it. Give you $9,065.64. Okay, so that's how you do it with the calculator on your computer. It's x raised to power y, so you take note of that. All right. Okay, number two, Find the present value P if this is this. So A is equal to P 1 plus I raised to power n. So this means that P 1 plus I raised to power n is equal to A. Please, literal equations. This is literal equations. You want to make P the subject of the formula. So P will be A over 1 plus I raised to power n. Okay? So P will be, our A is 900 over 1 plus I. 1 plus I is 0.044. Then raised to n is 91. So this is P will be 900. You do this step by step. Remember PEMDAS. You know what I mean? Remember PEMDAS. P will be 900 over. Now, you first of all do the parentheses here. If you add it up, it will be 1.044, then raised to power 91. Okay, now I'm going to tell you how you can use your calculator on the computer to do this kind. Because it will waste time writing it out, you know. Now, this, you have to do it step by step. If you want to do it step by step, you have to find what P is, 900, and then you find out what this value is, and you divide. But it's going to waste time, okay? It will waste time. Now, what you can do is to use the memory on your calculator. Now, if you have my calculator, this is the way I will do it with my calculator. I have something that says answer here. Answer is written with orange color. So that means I have to press shift before I use it. So first of all, I'll do 1.044, then raised to power. This is the raised to power 91, and it gives me 50.532 and so on. Then this is the answer, right? This is my answer right now. So what I will do, I'll do 900 divided by, but before I do divided by, I'll press, I'll do 900, then I'll do divided by, then I press shift, then I press answer, the answer that is here. Answer that is here to give me answer. Answer, then I press execute. So it gave me 17.88533. So the present value will be, 17.89. That's the present value. 17.89. Okay, now how are you going to do this with your calculator? You will have, with the calculator on your computer, you will have to play with this to get to know, you have to play with this a lot. Calculator on your computer has what we call M. It has the M, MC, it has the MR, it has the MS, it has the M plus, and it has the M minus. Okay. Change memory, recall memory, save memory, then add to memory or subtract from memory. Okay. Now, what you want to do is first, you want to do 1.044, right? And if you're using the calculator on your computer, please do it several times to make sure you have your right answer. You have your answer right. Okay? So 1.044 raised to power. So I press X raised to power Y. Okay, then I press 91. Then I press equal. So it gave me a lot of figures, 50.3205 and so on. So what I want to do now is, I don't need to write out all these and keep it in my book. Then I now do 900 divided by this. So what can I do? What I will do is just to put this in memory. So I press M plus. If I press M plus, M comes up. So this means that this figure, this number is saved in the memory. So what I will now do is, I'll now do 900, and I'll do 900, then I will do divided by, this / is the division sign, divided by, Then I will do recall memory, MR, memory recall. Some calculators have it as recall memory. Okay, and I'll do equal to, and it gives me 17.89. That's 888.88533, and you round up 17.89. So you will save it in memory, and then you recall memory if you're using the calculator on your computer. Okay? All right, that's number 2. So if you ask to interpret this means that if you deposit a sum of $17.89 to a bank that pays interest rate per compounding, annual interest rate per compounding, annual interest rate compounding per period of I of 0.044, then after 91 total compounding periods, you will have an amount of 900. That's what it means. Okay, let's do number 3. And you know what? We can now erase this to have space. So I think I've shown you this. All you need to do now is to play with it. Okay? So we'll be a bit faster now. Find the interest rate of compounding. Find the interest rate per compounding. Okay, per compounding. Find the interest rate per compounding period, I. They asked us to find I. If the annual interest rate is 9% compounded monthly. So, now, I didn't know whether I gave you this formula. I is equal to R over M. I is equal to R over M. Yeah, I gave you the formula, yeah. So R in this case is 9%, which is 0.09, and M, compounded monthly, means 12 times. Okay, M is 12. So I will be 0.09 over 12. What is it? 0.09 divided by 12. So that would be 0.0075, right? 0.0075, right? Now, this is 0.0075, but if you want to, remember, this is R over M. So your I, what is the unit for I? Unit for I, that is percent per period. Percent per period. Okay, that's the unit for I, percent per period. So if you want to change this to the unit actually for I, then you multiply by 100. So if you multiply that by 100 times 100, 1, 2, it will give you 0.75%. Then per, the period here is month, per month. So just like your rate, you know, the rate, if we want to use it, we have to convert to decimal. But if we are asked to find it, we will convert to percent. The same thing with I. Okay? That's the same thing with I. If you want to use I, you convert to decimal. But if you're asked to find it, you leave it in percent. Just remember what we said in simple interest. Okay? Alrighty. Now, number 4. Number 4, and we are moving on. We'll soon end this. Find the annual interest rate R. If the interest rate per compounding period is 2.575% per quarter, round to 3 decimal places as needed. Round to 3 dp as needed. Okay. R, they asked us to find R, and they gave us I per quarter. So that is 2.575% per quarter. Now, if we have to find if we have to use I, then we have to do what? We have to convert it. Remember, if they ask us to find it, then we have to convert it to percent. But if we have to use it to find something else, we change it to decimal. So this will be 0.02575, right? Because it's 1, 2. Okay? All right. Now, per quarter. So what is N? M is quarter. Quarter is 4 times. Okay? So you know that I is equal to R over M. So R is equal to I times M. So R will be 0.02575 times 4. Okay, we're now asked to find R. That means that whatever we get, we'll convert it back to percent. Okay? So 0.02575 times 4. And that is 0.103, which is what? When you multiply by 100, 1, 2, it gives you 10.3%. Okay, now listen. This is the answer you got, 10.3%. They say you should run to 3 decimal places. If they insist that you must run to 3 decimal places, then it will be 10.300%. But they said as needed. So if they say as needed and you just get 10.3, leave it. Now, but if you got, assuming you got 10.35217.8%, assuming that is what you got, then you round to 3 decimal places, 10.352%. You now round it to 3 decimal places. But if you solved your question and you got just 1 decimal place or 2 decimal place, you leave it. This is as needed, so you leave it. Okay? All right. Okay, the next one. I now have a lot of space now. Aha. Okay, number 5. Jane's parents deposited a sum of $6,000 in a prepaid college account. How much is this money worth in 18 years if it is invested at 5.9% compounded quarterly? Now, that reminds me, you know that at the beginning of at the beginning of every video that I teach, I try to tell the students, why are we learning this topic? Now, it is evident, this deals with money. Assuming you want to pay into account for your retirement, 401k plan, 452b is a lot of those accounts. You find out how much interest they pay and whether it is compounded. How is it compounded? What period? Is it quarterly or monthly or semi-annually? So if you pay money into such account, you know by so number of years, this is the amount you expect. Ceteris paribus now, okay? I say ceteris paribus because the market is unchanging. I mean, it's not, sometimes the market changes, the market is dynamic, okay? And I'm sorry to say, but you have so many greedy folks at Wall Street. They mess up the money, you know? They can't manage money, they just mess up the whole money. I mean, you have so many greedy folks. Now, I'm not saying that you don't have innocent people, you know, but you see, it's not good. You see people that they have been struggling, they've been paying the social security, they've been paying all this amount. Yeah, social security is an entitlement now. And you now want to cut it. What they have been suffering all these years and paying, it is not good. And you have some people that are making millions from these accounts. It's not good at all. So all this is, you know, on probability. These calculations are based on probability, ceteris paribus. Okay, so that is the thing there, right? Okay, let's stop talking politics. Let's go. Okay, now number 5. How much is this money worth in 18 years if it is invested at 5.9% compounded quarterly? All right. Now, in this case, what formula do you use? Remember, I gave 2 formulas, P1 plus R over M, MT. and then A equal to P 1 plus I N. Now of course you know that I is equal to R over M, and then N is equal to MT. Yeah, I mean if you look at it, I is equal to R over M, and N is equal to MT. N times T. Okay, so which formula do we need to solve this? They gave us the sum of $6,000, which is P. And how much will it be what? So the amount, the future value A, is what we are asked to find. Then in 18 years time, which means T is 18 years, if it is invested at 5.9%, R is 5.9%, we are going to use it to find something, so we will change it to decimal. Then M. So you see, this is the one that we will use here. This is what we're going to use. Okay? The first one is what we'll use. So A will be P is 6,000. Then parenthesis 1 plus R 5.9%. 5.9% means 5.9 all over 100, which is 0.059, right? So 0.059 then over what? M. M is quarterly. Quarterly is 4 times over 4. Remember, in that table I just gave you. Then 4 times 18. So A will be 6,000 1 plus. Now, the thing there is, it will take time to come and start doing all this. You divide by this, then you raise it to this. I will show you how you can do it with your calculator and keep moving. Now 4 times 8 is 32, 72. Okay. So we do it like we've been doing it. Now in this case, you do the parentheses first. Remember your B PEMDAS. Now, but inside the parentheses you have an addition and a division. The division comes first, so you do the division first, then you add, then you do the exponent, then you multiply. Okay? So I will first of all do 0.059 divided by 4. It will be 0.01475. Then you do plus 1. It gives you 1.01475. Then you do raised to power 72. It gives you a bunch of stuff. 2.8698. 2.869804.546. Let me log on here because I'll show you how to do this with this to save memory, change memory. Yeah. Okay. 2.869804.546. Then you multiply by 6,000, and it gives you. This is what I got here. $17,218.83. $17,218.83. Okay. Now, this is with my calculator. You know, it's kind of straightforward to do with my calculator. Just follow the order of operations. Make sure you watch my video on order of operations. Now, assuming you have the calculator on your computer and you don't want to be writing, because I did this, did I write anything? No, I just did it immediately and got the answer. Now, what if I had this on with a calculator here? Then, of course, you do first 0. Now, with this memory first, change it. Now you can just change it by change memory, MC, and we can remove memory. If you hit MR, you remove the memory. Yeah. So now let's begin afresh. 0.05959 divided by 4. So that's the first thing you do, first division, equal to this. Then you add plus 1, order of operations, one at a time, okay? it gives you this 1.01475. Then you now do x raised to power y, which means raised to power 72. Okay, here you don't even need to even use the memory. So it gives you this, then you do times 6,000. And it gives you this. Yup. Okay? You didn't need to change change memory. But sometimes you might need to change memory, that is MC, or you might need to remove memory. If you store the memory and you want to remove memory, it's MR. Okay? Alright, now, any question with this? Hope you understood it. Alright, now let's do the last one, question 6, then we call it a night. Question 6. Joe wants to have $16,000 in the future. He intends to deposit some money in a company that pays 9% interest rate, compounded semi-annually. A. This question has kids. It has two kids, A and B. A. How much should he deposit 5 years from now? B. How much should he deposit 10 years from now? Okay, so now he wants to have 16,000 in the future. So that tells you they give us A, right? And they want us to find the present value. How much will he deposit 5 years from now? Okay, so we have A equal to B, 1 plus R over M MT. Now, of course, I bring this over here. 1 plus R over M MT equal to A. Then I divide both sides by this. A over, B will be A over 1 plus R over M MT. Okay, so let's do this now, okay? Now, what is our A? Our A of, so B is, our A is 16,000 over, let me remove this dollar sign so it doesn't confuse and this letter in the final outside put it. Okay, then this is 1 plus R is 9%, which is 0.09. Okay, 0.09. So this is 0.09 over N. Semi-annually means twice a year. So over 2. Then M is 2 times time is 5. Okay? So we do this the same way, but we now save it in memory. Then we do 16,000 divided by recall memory. Okay? So 0.09 divided by 2. 0.09 divided by 2 is this. Then plus 1. Just do this, then raised to power 10. Now, yeah, this means raised to power 10. Don't forget, this is not 2.5. This is 2 times 5, which is 10. Okay, you do this, then I have my answer here. Then I do 16,000 divided by shift my answer. And that gives me $10,302.84. Okay? $10,302.84. That's what it gave me. So try it on your own, okay? And then for 10 years from now, so this is 5 years from now. 10 years from now will be 0.09 divided by 2 plus 1, then raised to power. It will be 2 times 10, which is 20. Raised to power 20, and then I now do 16,000 divided by shift answer. B part will give me $6,634.29. This is what it will give me, B part. Okay, so yeah, if he wants to get that kind of money 10 years from now, he will start depositing. He will deposit 6,000. He will deposit lesser amount. But if he wants it fast, quick, 5 years from now first, he will increase the amount. Okay? All right, thank you so much, students, for listening to this video. Hopefully I will do a second part, but this should get you started. Hopefully I'll do a second part, compound interest part 2. Now, this video will be on my website, www.samuelchukwuemeka.com. Okay, so, and if you have any question, feel free to send me an email, okay, or call me or text me, whichever one. But this video, the link will be there. And down, there are compound interest calculators. There are compound interest calculators on this website as well. So what you need to do is, if you log on to this website, click on my picture to enter the site, click on mathematics, click on finite mathematics, and once you're in finite mathematics, it brings you to the videos. Okay, this will be under interest and annuities. Okay, this video will be under interest and annuities. So, but if you want to use the calculator, you click on resources. You have videos, you have notes, you have resources. Click on that same page, finite mathematics, click on resources, and you will see the calculators there. Most of the calculators there have compound interest formulas, especially the one that says the easy calculator. And I said great or very great. Yeah, it has compound interest calculator. And as well, that's another one I have there. Okay, just play with it, you will see it. All right, thank you so much for listening to this presentation, and you have a good evening.